Okay, we're going to walk you through how to do the friction force worksheet here. Um, like I said in the demo tutorials earlier, is this math may or may not be above what a normal seventh grader can understand. So really, what I want you to do is really just understand the main concept here is that friction is going to slow down your vehicle, and less friction is going to be better. So that's really the gist of it. But here, what I'll do is I'm going to walk you through here the friction force worksheet. I'm not going to hold this entire worksheet you accountable for getting these answers right. Really, I just want you to go through here and see that there is some higher level math involved with engineering. So I will walk you through here just so you can even get the right answers here. I'm going to walk you through how to do this though. First thing here, just kind of, you've gone through a little bit of our different our research here, and you did read the friction force worksheet, or at least go through it. Really what I would refer to, it tells you here to go back and just kind of refer to some of the equations that they threw at you. And like I said, this is a little bit higher end math than I would ever expect you to know right answers for. But what we're going to do here, we do have one problem. It's asking here, it says if the dragster body weighs 0.8 newtons, what is the reaction force at the rear axle assembly? Now, up above here, it tells us that each one of these reaction forces has a certain amount of the total weight. In other words, it says here 35% of the car's mass pushes down on the front, and 65% of the mass pushes down on the back. Now, if you add those two numbers together, you get 100%. There's two axles, therefore, 35% on the front, 65% is pushing down towards the back. So the question here is, it asks, dragster's body weighs 0.8 newtons. What is the reaction force at the rear axle assembly? So we got to figure out what the reaction force here is. And really what you're doing here is with this problem here, you're pretty much just multiplying two numbers. So what we're going to do, they've given us the 0.8 newtons. Take your 0.8 newtons, we're going to multiply it, but whatever percentage it's asking you for, as far as this goes, it's asking us for the rear. So if we go here and we say 65% of the rear, so we're going to take the numbers of 0.65 and we're going to multiply that by our given weight here of 0.8 newtons. So let's do this here on my calculator. 0.8 times 0.65, we get 0.52. Now, in that case, let's see if we have an answer there, and yes, we do, 0.52. There's the correct answer. Now, we've got that figured out. Now, the next number 2 actually goes in, and it kind of builds upon what we found there in number 1. It says, what is the friction force at the rear axle if the rear axle is steel and the rear bearing is a plastic straw? Now here, we're just going to use the chart that they've provided us with. There's a lot of provided numbers here, and as a 7th grader, there's no real worry you need to take into account where these numbers come from. Just take them from the chart and use them to plug into the equation. All right, so here it's asking us for rear axle being steel, rear axle with a plastic straw. So use the chart. Steel, plastic straw. Here's the number you're going to use to punch in. It's 0.0554. We're using the previous calculation right here in our calculator, 0.52. We're going to multiply by 0.0554 equals 0.28808. Let's see if something similar is in our answers, of which it is. There you go. Question 3 here. Question 3 asks, what is the reaction force at the rear axle assembly if we can use aluminum instead of steel? So we're going to use the same equation that we just used, but we're going to change the type of material that we're going to use for the axle. So we go here to aluminum, and we're still using a plastic straw. So here's your number, 0.0325. So let's make that 0.0325. We're going to multiply that by our answer in number 1, which was 0.52. Your answer there is 0.0169. Let's see if something comes up here. 0.0169. There's our correct answer. Now, moving on here, we're just going to go to the next one based on your answers in 2 and 3. Was it a good decision to change from a steel or an aluminum axle, and why? So this is kind of the gist that I'm looking for you to get out of this. The steel axle gives you 0.288 newtons of friction force, and the aluminum gives you 0.0169. Which one's greater? The steel axle is greater. So the idea is friction on a vehicle is bad and it slows down your vehicle. At this point, we want to make sure that we have less friction. So the answer here would be 0.169, which is our aluminum axle. And here, your answer would be yes, reduction in friction force will result in a faster car. Our last question here, number 5. Which bearing type would provide the best results if aluminum axle were used? No math here, you're just referring back to our chart. Aluminum. What we're looking for is we're going to be looking for the lowest number. So if you can kind of rank these, 0.5, 0.10. Our answer here is 0.018, which is slightly less than this premium bushing. Probably costs less too. We'll get into that in another lesson. You can really improve the way that your axles move by selecting the right combination. So we're going to go aluminum with with laminated tube. And there you go. So that'll get you a 5 out of 5 on that. And like I said, I'm not holding this higher end math to that standard just yet. I just wanted you to get in and kind of see that less friction is better for your vehicle design.